Hello, my name is Dmitry. Welcome to the DPLabs channel. In today's video, you will see the awarding of the deserving winners of our contest. Today we have Denis from Ulyanovsk as our special guest, who impressively won in the category of electric ATV. He will now tell us about the unique features of his project. Please, go ahead.
So, good afternoon everyone. Look, there was an initial, quite comprehensive, etc., where all the essential main points were clearly and thoroughly specified. That is, regarding the crucial suspension system, the overall design aesthetics, the powerful motors, the long-lasting batteries, their inherent limitations, and their subtle nuances. Actually, I truly understand that many of you probably have significant concerns and valid questions, and I wholeheartedly share your sentiments. I'm also not completely satisfied with the project, and I fully understand where its shortcomings and flaws are, and how all of this can be addressed. The main thing is to have this understanding. Let's quickly go over the basics. The blue body that you see is just an idea. It does not possess any mounts or segmentation whatsoever. In other words, it has been meticulously crafted and designed so that we can truly gain a much more realistic and authentic sense of what we are actually receiving and acquiring. Therefore, the primary and most significant essence truly lies within the fundamental frame and the overall thoughtful layout of this particular item. Device. Let's take a look at the main components. I think for simplicity, let's hide the wheels for a moment. So, in the front, we had a conceptual suspension system chosen, meaning, as Dmitry specified in the technical assignment, existing units and parts were used in the design process. This included components like shock absorbers, brake discs, pads, drives, and other essential elements. You get what I'm getting at. Every component was selected from existing components. During the design process, a significant amount of documentation was studied. For example, documentation related to already existing ATVs, that is, various types of quad bikes, was reviewed. I took several different models of quad bikes to study in depth in order to get a complete understanding of the subject matter and its requirements. Specifically quad bikes. These were Yamaha, Polaris, Segway, and Can-Am. Each of them had its own design scheme. I'm just showing a few pictures so you can understand. It was thoroughly studied why they are made this particular way. In fact, there is a clear understanding of what they wanted to show with this design and how they implement it. So it was quite detailed. For example, here are completely different frames on two more or less similar quad bikes. There are no explicit dimensions here, so you won't find any precise overall measurements or anything like that anywhere. You can only visually see the picture, how it is positioned and connected together, and draw conclusions from that to understand the dimensions of some critically important components, since the documentation doesn't always provide all the essential information you need. We take the picture, add it to CAD software, overlay dimensions on it, and then try to correlate them. To accurately correlate them, actually, what else did I really want to say? The main elements for the engine were carefully added. The robust suspension system, everything necessary for optimal function, precise steering rods for accurate control, the essential stabilizer bar, and all the secure mounts. Moving onward to the concept of zero steering, a highly efficient electric power steering unit was thoughtfully added to the system. That's more or less exactly how it actually looks. Accordingly, at the very front we have the differential and two powerful motors. Yes, this layout was chosen. Maybe later Dmitry will say that everything will be completely changed, as you might have already guessed, since there are several distinct directions of work in this particular project. You can probably easily guess which specific motors, controllers, and so on will ultimately be used. So, this current layout is not entirely final, but you can already clearly get the general idea. Why, for example, was the motor specifically chosen to be positioned on this particular side? Because there were very strict and precise requirements for the overall size of the batteries, the main controller, and the integrated charger. So fitting them into this space was not exactly easy. Yes, you might say that there is a lot of space here. But first of all, the cooling system currently looks like complete nonsense. I understand that perfectly well. It
looks quite indeed strange. It
is strange, yes. Because you might say the hot air goes and for some reason ends up here. I had 3 minutes, so we worked with what we had. In theory, cool air typically comes up to the equipment compartment from below. Warm air is then efficiently vented from the top and subsequently exits through the exhaust at the very back. There are also two distinct radiators, one positioned in the front and another one in the back respectively, one specifically for cooling the front electric motor and one for cooling the rear electric motor, or quite possibly the controller and the charging unit as explicitly specified in the detailed technical requirements. So if you were to disable the differential, the comprehensive cooling system effectively protects the motor, the underbody components, and the crucial batteries. A simpler view. That is, let's put it this way. Do I like the current version right now? No, I don't. Because a lot of things were not done the way they should have been. You can see that there are a lot of extra components cluttering up the back. In fact, the green color highlights this. This was done because a mistake was made during the frame design. But I noticed it too late and time was running out. Well, there's still some work to be done, but the main requirements were more or less successfully met, I sincerely hope. Because after all, the basis was real components, the ones used in existing quantum cycles. I can tell you a bit about how, in general, the process of creating this went. Yes.
Let's just do that right now. Many people often say it's impossible, far too difficult, and that some of the requirements were quite unrealistic, but I'd really like to tell you exactly why I did it. Because in extreme situations, roughly speaking, that's when people are truly tested. I mean, basically, well, it was necessary to do some filtering. Well, yes, something like that. Then whoever just really managed, let's put it that way.
Actually, before starting, I thought for a long time about whether it was even worth beginning. Because if you start, you have to see the project through to the end. That is, not just create it and, let it just roll on its own. No, I mean, if you've already created a project, you have to see it through to completion, to actual implementation. So at first, I spent a long time in December thinking about whether it was even worth getting into all of this. And I set aside 2 weeks, meaning 12 to 14 hours a day, without getting distracted by any other work. First of all, I thoroughly studied the entire topic of ATVs, understanding how these vehicles are generally set up, because my professional background is primarily in aerospace engineering. I'm much more of a specialist in that particular field. But considering that there is a good deal of documentation available online, and even comprehensive video reviews can certainly give you a clearer idea of what you're truly dealing with after a few initial days, I really started to get into the topic. Little by little, I began sketching out my ideas on paper, gradually transferring everything into a three-dimensional model within CAD software. Naturally, I did perform some preliminary calculations, even though the entire design was modeled in Siemens NX. I specifically did the calculations in T-Flex. It was just much easier there. I certainly understand that Siemens NX truly has its own strength analysis, but everyone works in the specific way that's most convenient for them. The main thing is always the final result. It didn't quite work out perfectly the very first time, but eventually I found the optimal diameter for the pipes and the appropriate number of elements, more or less. It doesn't look absolutely great, but it's certainly good enough to effectively start with. You definitely need something solid to build on to truly understand what's ultimately unnecessary and what's absolutely not. Well, that's basically how it went. Basically, yes, it was 2 intense weeks of working 12 to 14 hours a day. You wake up thinking about the ATV, you go to sleep thinking about the ATV. That's just how it is for me. I can't do it any other way. Otherwise, the project wouldn't have turned out the way you see it now. Well, I guess that's it for me.
All right, well, I sincerely hope, gentlemen, that you now fully understand precisely why the first place rightfully went to Dennis, and I truly believe there won't be any more lingering questions about this matter. For some reason, everyone focused on the design, but he just wanted to... That's right. I mean, if you're presenting something, you really should make it look good. Some people just judge things by their appearance. Of course, we weren't primarily focusing on the design itself, but I liked... What really mattered here was the approach to the work, because, of course, it's not... We can't just take this and make a prototype out of it. There's still a lot of work to be done here. And all sorts of other things too. But at least it's clear that Denis, maybe his qualifications and his approach to work, which I really liked, stand out.
Why is it called Beaver? Well, if you saw the renders in the previous video, why Beaver? At some point it started to look like a beaver.
Yeah, it does a little bit.
I didn't plan for it to look like that. Fate. But that doesn't mean it will stay that way. Naturally, when we eventually get to the main body, there will be a comprehensive discussion. Everyone will share their individual wishes and will proceed accordingly from there. Right now, as far as I understand, the main thing for us is the structural frame and getting it ready for the first test run. That is, to put in the absolute minimum effort needed to truly get it up and running, test it thoroughly, and then figure out precisely where we initially went wrong, and of course to subsequently make it significantly better.
So, gentlemen, what have I been thinking in the current economic and political situation? Making a fully functional prototype of this particular quad bike right away would be quite difficult indeed. And not just difficult, there's absolutely no guarantee that it would be commercially successful under the current economic circumstances. It's also rather complex, and we could potentially make a lot of costly mistakes. Furthermore, this specific quad bike also inherently requires us to build a prototype. I'm afraid we'll have to postpone this until better times. The reason is that the market situation has changed, and I'm simply afraid that during the process of manufacturing and refining the technology, there will inevitably be some mistakes and modifications which will end up costing us quite a lot. But as our extensive experience with our, the four-wheeler, which, excuse me, was basically constructed out of mere sticks and mud, has clearly shown, it truly proved its worth during the summer season. It was indeed a beast. It effortlessly hauled big trailers and so on. Everyone here in our community used it, and even in winter we put on super studded tires and it consistently kept running. I suggested to Dennis that we develop a truly simple, inexpensive ATV. We'll have two distinct versions, all-wheel drive and rear-wheel drive. Right now, Ivan and Nikolai are diligently working on the rear differential, and I genuinely think this will be more commercially successful. Of course, you might understandably say, well, we certainly told you so. No, I could basically invest the money and really make it happen, and then, but who do I need to prove anything to? I won't prove anything to myself. I really needed to be realistic about this situation. This particular ATV is essentially a fun toy for me, and it's also something that is greatly enjoyed by many other ATV enthusiasts. I even understand that you wouldn't take it to the Kola Peninsula. But here, you can certainly take it for a really exhilarating ride like this. To give a very good friend a memorable ride so he truly remembers it for the entire rest of his life, because I fully understand that with that kind of immense engine power, it would be something else entirely, something truly extraordinary. But we'll definitely get back to this. Life will inevitably change, we'll certainly come back and do it. And at the very same time, on a much simpler ATV, we'll meticulously work out many crucial technological aspects, because ideally, it absolutely wouldn't hurt for us to acquire some specialized dies for precise bending, well, some essential tooling, because for us, aside from this particular four-wheeler, it's merely so-so, but it will also be a completely new and valuable experience. But I'm sure there's no need here, as you say, for people not to work. There are a lot of man-hours involved, and so on. The deserving winners in all the other important categories of our competition, unfortunately, couldn't make it here right now to join us, because we understand that everyone has their own problems at the moment and so on. But not everyone can come right away either. All of the cash prizes have been paid in full. Now, you will see some additional valuable and insightful comments from our esteemed and fortunate winners.
Good afternoon, everyone. My name is Dmitry Filipov. I am a participant in the competition that was announced on the DPLabs channel in the category Traction Motors for ATVs. In accordance with the technical specifications, a design for an electric motor was proposed with the following calculated parameters. Continuous electrical power of 25 kilowatts, with a peak power reaching 50 kilowatts, continuous rotational torque of 25 Newton meters, and a maximum torque of 60 Newton meters, along with a nominal rotor speed of 10,850 revolutions per minute. To effectively meet these precise and demanding specifications, a novel design for an axial flux electric machine without any electrical steel was thoughtfully proposed and subsequently developed. Such machines have a number of advantages. First of all, they are indeed very compact, remarkably lightweight, exceptionally easy to manufacture, technologically advanced, and possess significantly increased energy efficiency. What exactly is the fundamental reason for this remarkable development? Firstly, the complete absence of steel in the design entirely eliminates steel losses, especially since all modern electrical machines operate at fairly high frequencies of operation. As the frequency of the alternating current increases, losses in the steel material also increase. These are losses due to magnetization and eddy currents. In a machine where there is no steel present, there will accordingly be no steel losses. The second important advantage to consider is that electrical steel has an undesirable property, magnetic saturation. That is, the electrical circuit, the magnetic circuit, will have the property of magnetic saturation. This means that as the load increases, the characteristics such as useful power or torque will grow non-linearly. In a machine that does not contain electrical steel, this drawback is also absent. In other words, all the characteristics are completely linear. Furthermore, there is no need to set up an additional, specific stamping production process. That is, there is no need to stamp plates. Stamping steel plates always results, first of all, in waste. If you stamp in large quantities, there will be a lot of waste. And generally speaking, this is not such a simple or cheap production process. Permanent magnets. In such machines, the mass of permanent magnets is, of course, significantly greater than the total mass of the magnets found in many electric motors that specifically contain iron. But it is important to note that these materials are certainly not as prohibitively expensive as some individuals or groups often try to misleadingly claim. If mass production is carefully and efficiently organized, then all of this will likely be quite profitable in the long run. Some people express doubts about whether it is even possible to manufacture such a thing. That is all purely theoretical, but in actual reality that's simply not the case at all. There are numerous global studies, and in my very own laboratory we have specialized lab samples that we meticulously manufacture and rigorously test, all of which comprehensively confirms this important fact. I'd like to now show you our advanced test stand. Here we have a machine of a very similar axial flow type on significant and prominent display. A synchronous motor, a Mactrol TM311 torque sensor. In other words, all our extensive and thorough research is meticulously confirmed not only by precise calculations but also experimentally. It would be truly and genuinely interesting to manufacture a sample specifically for a quad bike, then install it directly onto the quad bike itself, and subsequently conduct comprehensive and detailed tests under conditions very close to real operation, and then compare it with some other various different technical solutions.
Hello, my name is Andre. I am one of the participants in the DPLabs laboratory competition for developing an electric motor for electric vehicles. I found out about this competition in mid-December from some acquaintances. They sent me a link to the YouTube channel. Well, first of all, not so much from the perspective of the competition, but more out of interest in the ideas and what people are working on. I looked through the materials, got interested in the project and the competition, and decided to take part in it. The entire project itself actually took me about a full month of dedicated work to complete. Approximately half of that significant amount of time was diligently spent searching for viable solutions and carefully thinking things through in detail. And the other remaining half of that month was specifically dedicated to meticulously putting together the actual project components. I was definitely quite surprised that, in the end, the laboratory is actively taking on such incredibly serious and significant projects. They comprehensively cover things like advanced inverters, robust ATVs, powerful traction machines, and efficient charging devices. So, of course, it's a truly very diverse and extensive range of important topics being thoroughly covered. Honestly, it really genuinely piqued my personal interest. What interested me most was the fact that the organizers themselves are very eager to get deeply involved in such a highly specialized field as engine building. Especially engine building. For electric transport, primarily because it represents such a significantly large and expansive market with a truly vast and diverse number of available solutions, making it quite challenging and complex to effectively identify and secure your specific position within it. Of course, what I would really like to say about the competition overall is this important point. For example, the organizers did something very interesting. They published all the results. They made everything as transparent as possible, open for everyone to see. And for me, as one of the active participants, it was truly very interesting from a professional standpoint and in a more general sense to carefully look at other diverse projects, not just those specifically related to electric motors, but also other fascinating ones across the entire and complete scope of work. That's a truly huge plus because they did not try to make it some kind of commercial secret. Instead, they made everything readily available for public viewing. They fully met all their obligations, of course. I was very happy indeed. I truly didn't expect to actually win this prestigious competition, especially knowing the high level of talented developers and engineers we proudly have in our country. I am personally acquainted with a great many of them. I have had the opportunity to speak with them extensively, and of course I was incredibly happy and truly delighted to achieve this victory. And I want to emphatically state that the organizers meticulously and completely met all of their stated obligations and commitments. I'm referring primarily to the monetary reward. Overall, I definitely have the motivation to continue participating in this work, because once I actually started doing something, it truly and very deeply got me quite interested. And now I want to bring all of this to life in hardware, to see a tangible product. After all, for an engineer, for a developer, it's an incredibly important moment when they truly see their innovative idea realized in fully working hardware. Well, that's about it. Thank you for your attention.
Hello everyone. I'm very happy to have become a winner. I want to express my deep gratitude to Dmitry for organizing the contest and for welcoming me as a guest. We had a very interesting time working together and checked everything thoroughly. I received my prize in full. Now we are currently waiting for the motor test stand to be fully prepared and completely ready so that we can meticulously run everything under realistic load conditions, because it's genuinely very interesting and quite important to observe precisely how it will ultimately perform in operation. Because no matter what, some nuances are bound to come up. I would also like to say that during the preparations for the competition, I discovered some interesting things for myself and found answers to certain questions that I hadn't gotten around to before, despite having experience. My experience was mostly related to servos, but there are their own distinct nuances there. All electric motors are usually very tightly and precisely regulated, and the intricate processes that occur when controlling the motor directly by its torque are carefully smoothed out. But here they were kind of exposed, and during the preparation I had to take certain measures to address them. I also want to say that I am very grateful for the competition that was held. It was very interesting, and I truly hope for further cooperation in this direction very much.
So gentlemen, the competition is officially over. The deserving winners are truly happy, and we have successfully achieved our desired results. And furthermore, besides the charging aspect, I am very, very pleased with the overall results. They are just absolutely fantastic, honestly. I honestly expected something much worse, but as it wonderfully turned out, the right and most capable people with the perfect approach genuinely showed up. In short, I got exactly and precisely what I truly wanted. I will definitely be working with those talented people again. In the future, I will certainly continue to hold similar and engaging competitions, but I just won't do so many at once because it was honestly quite overwhelmingly demanding and a bit much to handle. Once again, I truly want to apologize to all the participants for dragging out this entire process. We genuinely didn't expect it to take quite so long, but we absolutely wanted to be objective. We had to carefully look at and thoroughly review all the submitted projects. All the best. Subscribe to the channel, give it a like, and see you soon.